Hello, ladies and gentlemen. We're going to now analyze some rational functions. You've seen most of this before. The notation for the limit stuff is new, but for the most part, you should feel pretty comfortable doing this. So, first thing we're going to do is if I give you a picture and I just say identify the horizontal asymptote, so horizontal asymptote is right there, and that looks like it's at y equals 2, so we'll say y equals 2. Remember, horizontal lines have an equation that says y equals, and vertical asymptote would be right here. And that looks like 1, 2, 3, x equals 3, so x equals 3. We normally do these as dashed lines. Doesn't really make a huge difference here, but just so you understand, it's not part of the function. Now we're going to talk about end behavior, and we've done end behavior before, but this is going to look a little bit different. So let's do first the ones that we have done that sort of are more traditional, and that's the horizontal asymptotes. So for horizontal asymptotes, what I'm going to do is say the limit of the function approach or equals something as x approaches what? So historically what we've done is we'll say x goes to infinity and x goes to negative infinity. That's a worse infinity sign. So I'm going to write those first. These are for my horizontal asymptote. This says as x goes to infinity. So that means as we go to the right, as you go to the right, what is the y value getting closer and closer to? If you go to the right, notice how it is approaching y equals 2, the horizontal asymptote. So this is 2. And as it goes to the left, y is also getting closer and closer to 2. So when you're talking about horizontal asymptotes, you're saying what is the y value getting closer and closer to? Now, we're going to do vertical asymptotes, and this is a little bit different. So for the vertical asymptotes, the vertical asymptote is 3. So we're going to say as x approaches 3. Now I'm going to have 2 of these, and we're going to have to talk about y. X approaches 3. If you look at where x approaches 3, it's right there. There are two different sides to this. It's approaching 3 from the right and from the left. The way we say that, the notation we use, is 3 with a little plus sign, kind of like an exponent plus sign. That means 3 from the right. So as you approach this line, x equals 3, and we're saying from the right side, so from over here on the right side of it, the positive, it's going up. So this one would be positive infinity. Y is going up as you approach 3, and the plus sign means from the right side. Now, similarly, we have this other side, 3 from the left. As it's from the left side, as it gets closer and closer to x equals 3 from the left side, it's going down, so this one is negative infinity. So we're going to try and summarize this with variables and see if we can kind of flesh this out. So for vertical asymptotes, if the asymptote is at x equals a, we're going to say a, and this is on the right side, so a from the right. As you approach a from the right, this thing is going up to infinity. And this one is a from the left. We're on the left side of the asymptote, so we say with a minus sign, and this one is also going up, so it's up to positive infinity. Now, if we approach a from the right, see we're on the right side of it, and this one's going down, so this would be negative infinity, and this one would be a from the left, and that's negative infinity. So you have to decide which side of the asymptote you're on, and then you tell me is it going up or down on that side. Now, horizontal asymptotes don't have like it above or below. We don't say like it's approaching from below. It's just not something that we talk about because we're usually talking about the x's, not the y's. So when we say the x, here it goes to the right, x goes to infinity, we're saying it's approaching y equals b, and we don't have like above or below. And same thing here, negative infinity as x goes to the left, it also approaches b. So that's the notation that we use to describe end behavior. Let's do maybe one more, kind of wrap this all into one problem. So it says identify the asymptotes and then describe the end behavior. So the vertical asymptotes are at, let's see, x equals 2 and x equals 6. So I'm going to try and split this up, x equals 2 and x equals 6. And then I have a horizontal asymptote at y equals 1 right there, y equals 1. So I'm going to try and just organize my end behaviors based on the asymptote I'm describing. So first we'll do the vertical asymptotes. And I can see that there are 1, 2, 3, 4 endpoints, so I'm going to need to make sure I have 4 limit statements. So we'll say the limit of f of x equals as x approaches something, and I'm going to just try and see if I can copy that. Yeah, make this a little bit easier on myself. So there you go. So we have 2, 3, 4. Whoa. 2, 3, 4. All right, so the way this works, as x approaches 2, well, it does that from both sides. So we'll say as x approaches 2 from the left and 2 from the right. As x approaches 2 from the left, so that's right here, on the left side, it's going to positive infinity, and 2 from the right is going to negative infinity. 2, x equals 2, on the left side and on the right side. On the left side, it's going up, so we say infinity, and on the right side, it's going down, so we say negative infinity. For 6, we'll have 6 from the right and 6 from the left. 6 from the right, on the right side, that's right here, it's going up, so we'll say positive infinity, and down here, 6 from the left, it's going down, so that's negative infinity. Now we'll do limit statements for y, and I need 2 of those. So 1, 2. Oh geez. Get on there. There we go. Okay. So as x approaches, now these we're saying as it leaves the page to the left and the right. So we'll say one for negative infinity and one for positive infinity. Negative infinity, as x gets smaller and smaller and smaller, y gets closer and closer to the asymptote, which is 1. And as x gets bigger and bigger, y gets closer and closer to the asymptote, which is also 1. So you have a page of practice. You should probably do those right now. And I'm going to move on to the next section. But you can see that these problems, this end behavior practice, is just going through the end behavior. You should definitely do that if you're not in class. And now I'm going to go ahead and continue with the this keys on Schoology, the actual analyzing part. So do the practice problems. Now let's talk about analyzing algebraically. So when we say analyze algebraically, we have this big crazy function, and I want you to tell me basically the vertical asymptotes. So where are the vertical asymptotes? That's where you can just say the denominator is 0. So where the denominator is 0. If you set the denominator equal to 0, then you're going to have to figure out where that equals 0 and say, well, that's where the vertical asymptotes are. We talked about discontinuities. These are infinite or removable discontinuities. You set the denominator equal to 0 and solve. Now, horizontal asymptotes are a little bit trickier. There's sort of 3 different cases that we talk about. The first one is if the degree of the numerator is a lower degree. So for example, if you had x over x squared, we talk about the degree n and the degree m. So the degree of the numerator is 1 and the degree of the denominator is 2. This is our n and this is our m. That's what it's saying here. N is the exponent in the top, m is the exponent in the bottom. If you have a lower degree in the top, then there is a horizontal asymptote, and it's going to be the x-axis. It's at y equals 0. Now, what if they're the same? So if you have something like x cubed over x cubed, if they're the same, then let's say it's like 2x cubed and 1x cubed. Then you divide the leading coefficients. So these would be 2 over 1. This would be at y equals 2. But it could be other things. I just made those up. So this is when you divide the leading coefficients to figure out the asymptote. It's going to be y equals that, whatever their quotient is. And the last one is if you have a higher degree in the top, so like x cubed over x squared. This isn't going to have a horizontal asymptote. This is going to have a slant asymptote. And to find a slant asymptote, we're going to use polynomial long division, but we're going to save that for a little bit later right now. So let's kind of practice analyzing. First thing, to find the x-intercept, you set the numerator equal to 0. You set the numerator equal to 0. And to find the y-intercept, you set x equal 0. So first thing, x-intercepts. We're going to set the numerator equal to 0. 3x plus 5. When does that equal 0? Well, you would subtract 5 and then divide by 3. So the x-intercept is at negative 5/3. Now, that could be written as a vertical line. So anytime I'm talking about ordered pairs, I like to write them as ordered pairs. So this is negative 5/3, 0. The y-intercept is when you plug in 0. So if I plug in 0, I'm going to have 5 divided by 2. So that would be 0, 5/2, or 2.5. Vertical asymptote. To find the vertical asymptote, you set the denominator equal to 0. So when does x plus 2 equal 0? That's at x equals negative 2. So there's your vertical asymptote. And now horizontal, you have to think about the case. This is both degree 1, x to the first and x to the first. So when they're the same, when they have the same degree, you divide their leading coefficients. So in this problem, we do 3 divided by 1. The horizontal asymptote is y equals 3. So we're going to do a little bit of practice here of analyzing them before we get to graphing. But first, let's kind of summarize what we just said again. I'm going to type, make it easier on myself. So to find the vertical asymptote, you set the denominator equal to 0. Okay? To find the x-intercept, you set the numerator equal to 0. So vertical asymptotes, set the bottom equal to 0. X-intercept, set the top equal to 0. To find the y-intercept, you plug in x equals 0. Now you can also sometimes look at the constant terms or the polynomials on the end and do it in your head. But plug in x equals 0, that's how you find the y-intercept. And now the three cases. If you have a lower degree in the top, then the horizontal asymptote is at y equals 0. If you have the same degree, then you divide the leading coefficients. You can't see that. Divide the leading coefficients. And if you have a higher degree in the top, then you have a slant asymptote. Use long division. Okay. Which we're going to, like I said, we're going to do later. But you just need to remember those cases that we just talked about. So let's see if we can find these things. I'm going to see if I can make a little template here. X-intercept, Y-intercept, vertical, horizontal. Because I'm going to need 4 of these. 2. Okay. So find the x-intercept, y-intercept, and also the asymptotes. So x-intercept. To find the x-intercept, you set the top equal to 0. When does x squared equal 0? When x equals 0. So we'll say, again, ordered pair, 0, 0. Y-intercept, you plug in 0, so 0, 0, 0. That'd be 0 divided by -6, which is 0. Well, if it goes to the origin, that's the x and the y-intercept, so duh. Vertical asymptote, set the denominator equal to 0. So I'm going to factor this. Now I'm going to just kind of do it in my head. If you factor the denominator, it's x minus 3x plus 2. So that would be at x equals 3 and at x equals -2. There are 2 vertical asymptotes. Horizontal asymptote, they have the same degree. They're both degree 2. So you divide their leading coefficients. 1 divided by 1, that is y equals 1. Okay, let's try another one. X-intercept, numerator equals 0. When does 2x minus 4 equal 0? When 2x is 4, which is when x is 2. So 2, comma, 0. Y-intercept, when you plug in 0 for x, 0, 0, 0. -4 divided by 1 is -4. Vertical asymptote, denominator. When does the denominator equal 0? Again, I'm going to factor this. It's x plus 1, x plus 1. So the denominator equals 0 at x equals -1. That's where your vertical asymptote is. Remember, that's called an infinite discontinuity. Horizontal asymptote, that's when you look at the degree. So here the degree of the numerator is 1. The degree of the denominator is 2. And remember, if the degree in the top is smaller, the degree is 1 is less than 2, then we're going to say the horizontal asymptote is at y equals 0. So we've seen 2 cases now, when they're the same, and then here the numerator is a lower degree. Let's keep rolling. X-intercept, when does the numerator equal 0? When does 6 equal 0? It doesn't. There is no x-intercept in this problem. Okay, since you can't set the numerator equal to 0, 6 doesn't equal 0. So it'll never equal 0. That means there's no x-intercept. Y-intercept, plug in 0 for x. 6 divided by 2 is 3, so this is 0, comma 3. Vertical asymptote, when does x squared plus 2 equal 0? When x squared is -2. That's not real. That's a complex number. That's not real, so there is no vertical asymptote either. Okay, you're not going to say plus or minus I radical 2. That's a complex asymptote. That's not a thing, so that's not on the graph. Horizontal asymptote, here you have degree 0 in the numerator, and you have degree 2 in the denominator. So since 0 is less than 2, we say it's at y equals 0. Remember, that's that case that we just talked about. One more. I'm going to go ahead and factor this real quick, and then we'll talk about it. This is x minus 2, x minus 1 over, if you factor the denominator, you have x minus 4 and x minus 3. So x-intercepts, when does the top equal 0? At 2 and at 1. When x equals 2 or x equals 1. Y-intercept, if you plug in 0, 0, 0, 0, 0. 2 divided by 12 is 1/6. Vertical asymptote, when does the denominator equal 0? At x equals 4 and x equals 3. And then the horizontal asymptote, they have the same degree, so you divide the leading coefficients. 1 divided by 1 is 1. Okay, so that's it for analyzing. Now let's see if we can maybe do a little bit of the end behavior stuff and then maybe a little bit of creating a function. So end behavior. To do the end behavior, I'm going to, first of all, think about how many there be. 1, 2, 3, 4, 5, 6. I need to have 6 limit statements here because there's 6 places that this thing leaves the page. So I wonder if I have a limit. Let me see. Do I have a limit? Aha, look at that. We'll just say it's P of X. Okay. So I need 6 of them. 2, 3, 4, 5, 6. Just for this problem, there's going to be 6 limit statements. So let's see if we can maybe organize them a little bit based on which asymptote we're talking about. So first of all, vertical asymptotes are right here and right there. So that's at, I think that's at x equals 3 and x equals negative 3. So x equals 3 and negative 3 are my vertical asymptotes. So I'll try and structure this. For the vertical asymptotes, this is where x equals 3. So we're going to have 2 limit statements for this because it approaches 3 from 2 different places, the left and the right. So we'll say 3 from the left and 3 from the right. 3 from the left. So if you're on the left side of the asymptote, it's going up, so this is infinity. And on the right side of the asymptote, it's going down, so this is negative infinity. What about negative 3? So for this one, if you do negative 3 from the left and negative 3 from the right. So negative 3 from the left, that's up here, goes up. Negative 3 from the right goes down, negative infinity. Now we also have a horizontal asymptote. Horizontal asymptote is at y equals 1. So for y equals 1, I need 2 limit statements as well. And for this, you're saying as x goes to the right and as x goes to the left, it approaches 1 both times. As it goes to the right and the left, I'll draw that back in there. There you go. So that's y equals 1. The y value is approaching the asymptote, which is 1. And it's saying as you go to the right, so as x goes to infinity, and as you go to the left, x goes to negative infinity. Let's do another one. Same deal. I'm going to need 6 of these again. So I'll just kind of steal one. Okay, 1, 2, 3, 4, 2. There we go. All right, so let's see if we can list these out. Where are my asymptotes? That looks like it's at negative 2 and positive 2, and then looks like the other one is also y equals 2. So there's a lot of 2's in this problem. All right, so we'll say for first, x equals 2, x equals negative 2, and y equals 2. So we're going to have 2 of them for each. X equals 2. If you look right here, you have an endpoint here and down here. So we'll say 2 from the left and 2 from the right. 2 from the right, that's this one, goes up, and 2 from the left, so on the left side, that goes down. Negative 2, so negative 2 from the left, negative 2 from the right. Negative 2 from the left, that goes up to infinity, and negative 2 from the right, that goes down to negative infinity. Y equals 2, so the horizontal one, it's just going to be 2, and you say as x goes to the right, and as x goes to the left. All right, so we've done end behavior now. Last thing we're going to do is just sort of create a function based on what we know. So this says, suppose the function has x-intercepts at 2 and at 3. Well, you got to think, how do you get x-intercepts? That's when the numerator equals 0. So if a 0 of the numerator is 2, then a factor would be x minus 2. And if there's a 0 at 3, then x minus 3 as well. So in the top, I have x minus 2, x minus 3. In the denominator, it says vertical asymptotes are at negative 1 and 1. So that'd be x plus 1 and x minus 1. If I want these zeros of the denominator to be 1 and negative 1, those are factors. Now if you expand this out, you see x squared minus 3 minus 2 is minus 5x, and then negative 2 times negative 3 is positive 6. In the denominator, that's dots, so this will be x squared minus 1. If you expand it out. So where would the horizontal asymptote be, and where would the y-intercept be? Well, they have the same degree, so they're both degree 1. That means you would say you divide the leading coefficients, you get y equals 1. And the y-intercept, if you plug in 0, 6 divided by negative 1, the y-intercept will be at 0, negative 6. Let's do one more like that, kind of the same idea. It says x-intercept is at 3, that means the numerator equals 3. So x minus 3 would be a factor. And vertical asymptotes at negative 0.5. You could probably do this a couple ways. I'm going to say 2x plus 1. I want integer coefficients. You would subtract 1 and divide by 2. That's negative 1/2. And also at x minus 1. So now when I expand that, I have x minus 3 in the top. That didn't change. So you FOIL 2x squared minus 2x plus 1 is minus x, and 1 times negative 1 is negative 1. So where would the horizontal asymptote be? Well, this is a lower degree in the top. This is degree 1 over degree 2. So you say it's at y equals 0. And then the y-intercept, when you plug in 0, you get negative 3 divided by negative 1, which is positive 3. Okay. So that's it for analyze. You have my math lab over analyze. So go ahead and see if you can knock that out. We're going to do graphing next. And when we do graphing, you're going to have to do a little bit more work. So make sure you get the analyze problems done. And also hit that like and subscribe button.